what point? X naught, f of x naught. So the same point that the function has. I want my line to hit that point. And it has a slope of f prime of x naught. So the idea is the derivative is the slope of the tangent line. This is another concept for the derivative. And people will tell you that like it means something. That, hey, here's a useful thing about the derivative. Its slope is the slope of the tangent line. But if you inspect what that sentence is actually saying, well, the tangent line means the line whose slope is the derivative. So it's one of those sentences that doesn't actually tell you anything. But if you have these ideas of the tangent line in your head, then there is some content to that sentence. Anyway, let's try an example of this. Let's write down the function f of x equals, let's do x cubed minus 4x squared minus 3. And let's find the tangent line. Let's find the equation of the tangent line. To f of x at the point. Let's make it x equals -1. We've taken an algebra class. If you're in here, you should have taken an algebra class in your life. You're good at finding an equation of a line. It would be nice to know the point-slope form of a line. I'll tell you what it is. It's y value plus slope x minus x value. We have an x value for our line. We can find the y value for that point. It is f of the x value. That is the y value of the point of the graph. That's what it means to graph something. And our slope tells us, like the definition of the tangent line is the slope should be the derivative. So I need to compute the derivative. I need to also compute the function value. We will probably do that along the way to finding the derivative. And then stuff all that in the point-slope form. Let's try this out. I need f prime of -1. I approximate that by taking f of a number really close to -1. Let's make it -1.003 minus f of -1 divided by -1.003 minus -1. What do I get from this? These are numbers I don't want to try and... Well, the one on bottom I can do is -0.003. These I'm going to have to stick into a calculator. What is it I'm going to stick into a calculator? I'm plugging -1.003 into this. I'm going to show you a mistake people make. They'll plug in -1.003 cubed minus 4x squared. Now it's time to plug in -1. No, it is not time to plug in -1. I'm still in the middle of computing f of -1.003. To compute f of one number, you plug that number into all of the places where x is. And all of this is f of -1.003. Now, I plug -1 into the whole thing. -1 cubed minus 4 times -1 minus 3. This number I can do, that's -1 plus 4 minus 3. Oh crap, this is 0. I didn't mean to get a place where it's 0. That doesn't mess things up, but it makes it not the best example. I need to ask my calculator, what is -1.003 cubed minus 4 times -1.003 minus 3 minus parenthesis -1 cubed minus 4 times -1 minus 3. I'm being redundant here. I'm typing this number in even though I just worked out it was 0. Now divide that by -0.003. I get -0.990991. Ah, geez, it's -1. Why am I saying, oh, geez? I did the first example we did, the derivative turned out to be the same as the x value. Here this is happening again. Not on purpose. Coincidentally, it is also -1. I got a number very close to -1, a number so close that I might guess that the actual derivative is -1. I To confirm that, I could plug in even more zeros, but I can just say, hey, I'm going to round after 2 decimal places and say it's pretty close to -1 if it isn't -1 itself. So the slope, the equation of the tangent line should be y equals y value plus slope x minus x value, and I know all these things. The x value they gave us, we used a bunch, was -1. The y value they didn't give us, but we worked it out along the way. This number turned out to be 0. And the slope is the derivative that we just computed, was coincidentally also -1. So our equation would be y equals 0 plus -1 x minus -1. We can simplify this into mx plus b form, and occasionally maybe the homework will care. I don't really ever care. Just leave it as whatever. And the best thing about this, when you've computed an equation of a tangent line is something you can see. The function was x cubed minus 4x squared minus 3. I can look at that graph. Let's make our y window a little bigger so I can see more of what's going on. Let's make it -30 to 30. Oh, I changed the X window, not the Y window. Dang it. Let's go to standard zoom, and then let's change the window again. I meant to make the Y's bigger because the thing's going off the graph real fast. This will make it less steep, and we'll see it a little prettier. Alright, and according to our calculations, if I also graph the function -1, if I simplify that, that'll be -x minus 1. That should be the tangent line. Uh-oh. Something's gone wrong here. I'm going to pause it and figure out what. I figured out what. We lost the squared. That was an x squared. We didn't squared that, and we didn't squared that. Is that going to change the thing? Oh, now our y value isn't 0 anymore. That should have been -1 minus 4. -1 squared is 1, so -4 minus 3 is, now everything's negative. -8 is our y value. And our derivative, I don't know what that is. I'm going to use my second enter. Second enter. It's nice to make a mistake once so I can show off the second enter trick, but I didn't mean to do it twice. Insert a squared here. Let's insert a squared here. And now divide that again by -0.003. And I get an answer of 11.002, an answer so close to 11 that I would guess that the answer is probably 11. So that would make this an 11 instead. So our tangent line looks like it's y equals -8 plus 11 x minus -1. And if I say y equals that as the tangent line, when it's right, the thing I'm trying to emphasize is when you get these right, it looks right. I hit graph. My graph at -1 should be just grazing that line, and hey, so it is. Another way of describing the tangent line that would be a decent definition would be that it's the graph that when you zoom in on that point, the more you zoom in, the more it looks like a straight line. The tangent line is that line that it looks like. Like here, I see the line is just grazing the curve. If I zoom in on that particular point even more, that's the curved line. Here's the straight line. I can barely tell the difference. If I keep zooming in, there will come a point where I can't tell the difference at all. They look exactly the same. If the angle was a little bit different, that little bit of difference would be preserved as I zoom in and in. For the tangent line, that difference shrinks away. I think that's everything you need for 2.1. I'm going to call this playlist now. Hopefully tomorrow I'll be able to do videos longer than 10 minutes. I verified my YouTube account. I'll see if that fixes things. I'll see you later.